Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is easy task and it is a medium level problem. So like it's a quite of irony in itself. It says easy task, but it is a medium level problem. So like the problem statement starts with a string S and we have given Q queries, right? So the queries is of two types and we have denoted the types of the queries. If the queries is of the first type, what we have to do is we have been given an index and a character and we have to change the character at this particular index, right? Now in this query of second type, we have been given a range left to right and a value k. So we have to find the kth largest character in the string, and it says that it should be the kth largest character in the sorted order. Like for example, if you take the substring or in the range left to right, what you have to do is after taking it, you have to sort it, and the kth largest character should be the correct value that you have to return, right? So these are the two types of queries. Now, as soon as I read this question, the first thought that came to my mind was segment trees, or like finite trees can also be used for this particular purpose. But then I started thinking of some other approach since it is a medium level problem. But later I checked the constraints on this particular problem, and that were n plus q log n. So these constraints like somewhat resembles the segment trees type of data structures, because like n would be the building time and each query can be answered in log n time, so it is multiplied by q log, right? So I believe after checking the constraints, I thought solving it with segment tree would be a much better approach. So that is why I have implemented this particular problem using segment trees. Now, if you already don't know about anything about segment tree, then I would highly request you at this particular stage, or like even further, like you don't actually need to know segment tree. You just can consider it as a black box, and you just need to know two particular things. The first thing is what is the functionality of segment trees, and like a very basic understanding of what is happening in a segment tree. Why? Because like in any question, when you would want to modify the segment tree according to your problem, then you would need to know like which part is doing what. Then only you will be able to modify the template or the code, right? So like I'll be explaining both of the parts in this particular video, but you don't need to actually go into deep and understand how exactly a segment tree is working. So this is all I would say, and I would also leave a snippet to what a basic segment tree in the description of this particular video, so that you can check that out later on and you can use it anywhere. It's free to use, and like in that particular segment tree, I have implemented range sum with lazy propagation as well. So if you ever read segment tree, you would also know about lazy propagation. It is used in range queries and range updates. So for this particular problem, we have to use point updates and range queries. And let us discuss how we are going to use segment tree in this particular problem. So let us first have a sample test case. So in this particular test case, what is happening is we have been given AB. So this is the original string. Now the query is of first type. The indexing that they have said for the indexes is 0 based. So if you consider it as 0, 1, 2, 3. Now they say that we have to perform a query of type 1 at index 2 and we have to change the character to D. So index 2 is this and we have to change this particular character to D. So the final string will become ABDB, right? Now we have to tell in the range 1 to 3 what is the first largest character. So if you sort it, it will be B, T, T, and the first largest character is this one. If it asked what is the second largest, then it would have been this one. The third largest would have been B as well, right? So if the value of K was 2 or 3, the answer would have been B. Otherwise, the answer is 1. Now using segment tree, we will be calculating the frequency of all the elements in some particular range L to R, right? So whenever we perform a query on the range L to R, we will be getting a frequency array which will be denoting the frequency of all the characters. So for example, let us assume that we have these characters. So we have 6 characters here, right? So if the frequency of this particular character is let's say 2, let's say this is 3, this is 1, right? So if you want to find the second largest character, you would start from the back and keep on adding. So let's say we have a variable count which is initialized to 0 and you keep on adding this particular frequency. So first you add this particular frequency, it becomes 2. So if this particular count has a value 2, if the value of count is greater than equals to k, if the value of count is greater than equals to k, that means we have found a rectangle. Why? So let's say the first character was this, second character was this. Your count was initially equal to 0 from here, right? When you add all the frequency of this particular character, that means you directly jump to this particular position. If the value of k was somewhere in between, that means this is the only character that we are finding, right? If the value of k lies right to the right of it, we need to add some more characters. So let's say this was 4, this was 4 was present 3 times. Now we add 3 to it. Now the value of count jumps here, right? Now there must be one more character 3. When we add the frequency of 3, that is 1, and it becomes greater than or equals to k. As soon as it becomes greater than or equals to k, that means we have found our correct character, right? So this would be our approach. Once we get the frequency array in the range L to R, we have to traverse from the back, and we have to keep traversing it, adding the frequency of the count variable. As soon as it becomes greater than or equals to k, that means we have found our correct character, right? So this would be our approach for finding the character. Now discussing the segment tree part, I'll just quickly give you an overview what is a segment tree. So segment tree has 3 parts: build. And one more thing, like this, the same problem can also be solved with Fenwick tree. It is a similar kind of tree. You can also use it, and it's just that the code of Fenwick tree is a bit small, and it consumes less space. The overall time complexity is the same in both of the cases. I implemented with segment tree because I had the template for segment tree ready with me. So that is the only reason I did it with segment tree. You can also choose to do it with Fenwick tree, right? So Fenwick tree is also called binary index tree. You will find it easily on the internet. So for a segment tree, we have 3 parts: build, update, and query. So these are the only 3 operations we have to perform. The build operation will build the segment tree, update operation will do any updates that we want it to do, and query operation will perform the query in the range L to R. Right. So these are the 3 kinds of operation. Now I believe, apart from this particular last part where we have to where we need to know how to find the value of the character from the frequency array, there is nothing much to explain here. All the rest of the things is only in the segment tree, and let me just show you this code for segment tree now so that you understand it better. And the last part, you will observe that answering the queries is only this part. The rest of the part in my code is just segment trees. And even from this, you just answering the queries here, right? This is the for loop I was talking about. So let us first discuss the segment tree and how is it to just get an overview of the idea how it is working. So I just create a tree, a 2-dimensional tree, and it's of size 4 cross n. So 4 cross n, whenever if you read segment tree, they would always suggest if the input array is of size n, you always take the segment tree to be of size 4 times of n, right? So this is the standard size that we take for segment tree. Now we have this particular build function, and at whenever low is equals to high. So the idea is whenever you get a range, you divide the build function into 2 halves. So you calculate the mid, you call the build function on the left half, you call the build function of the right half, right? So it is dividing the task into smaller problems. And whenever low is equals to high, it means we have reached a single index, right? We have reached one particular point containing of only one index. There is no range now. So in this particular case, I initialize the frequency array of size 26, all with 0, and I just increment the frequency of the character present at that particular position. So you don't need to focus on the code now. I'm just explaining it to you. You can just hear what I am trying to say, and you will be able to get an overview or an overall idea, right? So if the character at a particular index, I'm just taking out the character and incrementing its frequency and assigning that particular frequency or the frequency array to that particular node of the tree, right? So this is what is exactly happening. So calling it on the left and the right side, this is the left side, this is the right side, and after all of this has been done, I just run a loop from 0 to 26, and I just merge the left side and the right side into the current node. So node holds the current node, 2 into node holds the left node, 2 into node plus 1 holds the second node, right node, right? So I merge both of them, right? So I'm just adding the frequency of the ith character in both of them into my current node. So this is how it is working. For the update thing, so if this is the case when I'm out of the range, this is my case when I'm in the range. So if I have to perform an operation in this particular range, since it is point query, the point will always be a fixed point, and this is the similar thing what we have done here, right? Since we have to change the character, I initialize it again. I just increment the frequency of that particular character and assign it to the current node. So this is exactly the same lines I've written here while building my tree, right? Again, I'm calling the left half to update. I'm calling the right half to update because I don't know in which half my update is put, right? So after this has been done, what we do is, again, similar to the build function, it is exactly the same thing. I just add the answer from my left half and the right half into my current. Now, talking about the query function, in this query function, again, it is a similar thing to the update function. If I'm out of range, I'll return this default frequency array where all of the values are initialized with 0. If I'm in the current range, then I'll just return a tree of nodes because this will be storing the answer for my current range. Otherwise, I can just find the answer in the left half, find the answer in the right half, and store the answer for the current range in this particular array by adding both of them, right? So it is similar to what we have been doing till now. So the basic idea of segment tree is divide the problem into left and right halves, combine the answer of both the left and right halves, right? So even if you did not understand what I was trying all along, what I was trying to convey all along, it is not a problem. You just need to know like an overview of segment tree, and you just need to consider it as a black box and use it, right? So the concepts like these are just there to for you to directly use in competitive programming or any problem solving contest. It is not necessary that you know the exact working of these all techniques, right? So there is as I've already said, I'll be leaving a snippet in the description. You can always check that out and use that snippet, and like it is tested by me in few other contests as well, so you can use it freely without any problem. So I just call the build function initially and I create my answer vector, right? So for all the queries, what I do is I just get the query. So queries is being given in the form of a double dimensional string vector. So I have to convert them all to integers. Like the first part is integer, I convert it into the integer, then I check what it is, and I take the input for the index as well as the character. So this is the query of the first type where I have to update. So what I do is, since my code was according to range query and range updates, so if I have to do point query, I am just passing the same index twice. So this is the left range, this is the right range. If both the left and the right range are similar, then it will perform the operation on one single index, right? So I'm just passing all the things to the update function. Similarly, I just take the input, and since my tree is one based indexing, so I'm just incrementing both index and LNR by 1, right? So similarly, I just take LR and K, I just perform a query on the range L to R, right? And I initialize my count with 0 starting from 25 till I'm greater than -1. I'm just adding the frequency. If count is greater than or equals to K, I'll just push back it into my answer. So I'm pushing the current character into my answer, and I can just break out once I found the answer. So at the end, after all of these queries are answered, I can just return my answer vector, right? So I'm saying it again. Even if you didn't understand the segment tree part, it's totally okay. You can just use it as a black box, and you just need to know what is the functionality of the segment tree. So I'm just going to submit this code quickly so that you can see that this particular code passes all the test cases. So as you can see, it has so it has passed all the test cases and the code is correct. So you can always implement it with Fenwick tree also, that is also correct. And these are just two similar approaches for range queries and range updates. So that was it for today's video. I'll be leaving the code for the segment tree only in the description as well, so you can check that out. So that's it for today. I hope you guys were able to understand the solution. If you guys did, then consider dropping a like on this video. Don't forget to subscribe to this channel. It's always free of cost, and you can always unsubscribe later if you don't find the videos interesting. So I see like a lot of people who watch these videos have not subscribed yet. So if you are one of them, please do consider subscribing. Share this channel with your friends. Until the next video drops, keep coding, stay safe. Bye bye.